Okay.
First of all, I want to welcome people that are here in the room. You cannot see, but we have quite a number of people that are physically here with us. And we also have people that are connected from remote. And it's nice to see that there is this interest. I just recap. The session is a paper session about smart buildings. And we have a different perspective, let me say, represented by 4 different presentations. We rearranged a little bit the agenda. So David from INESC will be the first presenter, and he will introduce us on more, let me say, technical aspects like solutions to make the data coming from smart buildings more interoperable, and to make them also accessible for cross-sectorial services. So I leave the floor to you, David. Thank you, and let's try to stay in the time slot that we have assigned to the speakers.
Okay, so good afternoon. Thank you very much for the introduction. So I'll be sharing this presentation jointly with Laura Daniele from TNO. And we're here to present you with the work that we have been producing within the InterConnect project. So one of the key points that we'll be discussing here today is one of the main outputs of the project, which is the Semantic Interoperability Framework that the project has been working on, and actually has been the main tool to enable what we call the cross-sector services within the smart buildings. And with smart buildings, we are approaching different types of buildings. We actually have some examples of the application of the interoperability solutions that we have on the pilots that we're developing. But I was saying we will be talking here about especially 2 kinds of buildings, so residential buildings and tertiary buildings, where different energy and non-energy related services are being explored. So the overview is quite clear. So we are here to present you with the background, overall the needs and what motivates the work that we'll be doing here, especially within the InterConnect project. Laura will dive into details of all of the semantic interoperability aspects, namely the ontology part, from which we depart as the grounds from SAREF with the ontology side, and she will dive into more technical related aspects of why this makes sense, how we depart, and how we are reaching out this to the field. And then we will be showing you 2 examples of what we call interoperability in action. So we have 2 cases here today to present. We are the pilot has 7 large-scale pilots. We have elected 2, the Dutch case and the Portuguese case, which we believe do present a relevant differentiation also that's related with the work that we're presenting in the paper. So background. We are facing right now from several years this pact from the Commission side with the Green Deal, which means that we need to create the conditions for several sectors from well, related with buildings, but related also within the use of energy towards the neutrality by 2050. And one of the points in one of the sectors, of course, is buildings. As we all know, they do represent a significant share of the energy use. And actually, they do have challenges on their own with regards to neutrality and to use of more efficient solutions on the end consumption, namely because we're involving end users, some of them not completely aware or not completely sensitive to the issues related with energy management. This means that we have a lot of installations, a lot of devices, a lot of systems that will be cooperating, mainly to make sure that, for instance, renewable-based integration solutions and strategies are actually seeing the complementary use of flexibility on demand side, which means that looking at these kind of devices, we need to find ways of interacting with them in a straightforward manner, and actually to facilitate these interactions between what is now called from several years the IoT-based domain of devices and systems. Ultimately, we are looking of ways in facilitating the introduction of energy flexibility services. So buildings are by nature clusters of different energy solutions. And we are now reaching out with the electrification of several domains within the buildings of finding new ways of using this flexibility as services. Ultimately, the idea is to create decentralized energy systems that can cooperate with each other. And this is why, as you will see today, it's fundamental to have this interoperability framework and to make sure that systems are connected like and that we remove the barriers actually that may still exist on the interoperability framework. Ultimately, we are dealing with large amounts of data that need to be timely shared among different stakeholders, different parties. and actually they do represent an important tool set to make sure that we actually continue to the energy transition. And one of the current initiatives within the EU is actually the Repower, and as we all know, we're being pressed to make better use of energy overall with the current context. So this is why it's even more important to have this interoperability framework. So the project, I won't go into much detail, but to tell you that the project is a very large scale project focused, which has very different stakeholders that are united here. R&D stakeholders such as ourselves, INESC TEC and TNO, but also service providers, technology providers, end users of buildings, associations, and even companies stemming from the end use of energy to the grid side, with ESOs also participating here. So all of this actually aims to create what we call a cross-domain semantic interoperability tool set and a framework that allows this kind of energy, non-energy service to be introduced in the several pilots. We also have, as part of the project, cascading funding, where we are now evaluating the first round of participants, actually to extend the 7 pilots that you can see here. So from Portugal, France, from Germany to the Netherlands to Belgium, Italy, and Greece. So these are the 7 pilots that we will be testing the solutions. As you will see today, we'll mention 2 of them, Portugal again and the Netherlands, where we can actually see interoperability becoming a part here. So passing on the word to the Semantic Interoperability Framework to Laura, I'll resume in a while, but this is the important cornerstone that Laura will talk about in the next minute. So Laura, passing on the floor to you, let me know when to change the slides.
Yes. Thanks, David, for the introduction, and thanks. Good afternoon, everyone. So if we go to the next slide, indeed, well, you probably all know there are several levels of interoperability, and in the past, starting from the connectivity, then and the network interoperability going higher up. And for a long time, and still nowadays, syntactic interoperability is the one that is most used, but there is also a very good understanding about the fact that semantic understanding and semantic interoperability is very important to make things interoperable, because there are so many things about buildings, but then in home, in the buildings, and then also in the smart grid, how many standard protocols that are there, and there is not one that can be used for everything, especially when you have to communicate across domains. So when energy standards need to communicate with building in-home standards, and then it becomes really a problem. So if we put an additional layer on top of semantics, then we need a kind of a common vocabulary about concepts that are in there, and we still use whatever are the solutions, the existing solution at the lower levels in this stack of interoperability that you see here. So if we go to the next, actually probably there is an animation. In InterConnect, we are focusing in providing, in scaling up, because the concept is not new. Of course, it's a long time that it's in there, and it's perceived and understood also by the industry, but being applied in a large scale, in concrete use cases, in such a big scale, this is something very specific of InterConnect. It's the first project where actually this is really happening across these domains. Again, I stress again that it's across home, buildings, and grids. If we go to the next slide, I think, ontologies are common vocabularies, and I think quite of the people here, there is also another project later, Domos, that is dealing with ontologies, and I think it's something that people know, at least the term. In practice, maybe no, they don't know what to do with that. Maybe we can help a little bit, and that's also what we faced, the challenge that we faced at the beginning of the project in InterConnect. But let's say that ontologies are useful means to create this interoperability, to exchange data and have a common knowledge about this. And InterConnect started as with a pillar in it was the use of ontologies, but especially some standardized open ontologies, which are the SAREF ontologies, standardized by EPSI. And it's a process that started very long time. However, we're not the first project to face this. Not all the concepts are already included in SAREF, because SAREF is an evolving model. which doesn't consider all use cases in one go, of course. And then we realized that, okay, then we have a lot of partners, a lot of pilot in InterConnect, a lot of use cases and services, as you can see there. We have more than 100 use cases, 66 services, a lot of APIs to connect together. And we needed to create new extensions of the ontologies. So we go to the next slide. And okay, so we based this on Saref. So Saref was a very good basis for enabling these cross services in smart cross services in smart buildings, because there is one Saref core model which goes horizontally, and then there are also a lot of extensions in different domains, and some of them are Saref for energy, Saref for buildings, Saref for cities. So we Saref for water. So we there was already a very good basis in there that we extended. And if we go to the next slide, the result of a lot of work in InterConnect is, one of the results, of course, is what you see here, which is an extension. So we created a lot, several new modules that you see in the gray part of the picture. And this is based on the lower part. So you see below there the Saref ontologies already existing, Saref, core, energy, city, building, and so forth. On the left part, you see ontologies, models that already are there, very well-known models that we also reuse in our work. And then, depending on the use cases, we created some new modules. I'm not going to present that, of course, but there are some links in another slide. I think what you obviously see is that there are some parts about flexibility, which have to help a lot here when we talk about energy flexibility in buildings. And some other modules are more like, and then you have user preferences, because, for example, yes, you have the flexibility, but you also still want to be able to address what are the user preferences, still optimizing flexibility. I think, and one important thing is, I think it's also a very important message to give, is that we started from Saref, and Saref comes from ETSI, from a standardization body. We extended this with the industry in our projects, but now we go back during the project to ETSI to standardize back these parts in Saref. So there is a sustainability, sustainable places, but also in terms of ontology, we are sustainable because we have an exploitation plan, because it goes back to ETSI. And then at the end of InterConnect, we don't have ontologies, InterConnect ontologies, but we have Saref ontologies evolved and maintained by ETSI. So if we go to the next slide. Thanks. Here you have some links, so we don't need to go through that, but you will have this slide later if you want to know more. So if we go to the next one, David. Okay, so at the end, what do we do with these ontologies, with these concepts and semantic terms that are in there? So we use them in something, well, there is a reference architecture that was developed in InterConnect. Of course, we didn't start from scratch, but we started from, anyways, having to bridge domains already existing. We took IoT reference architecture, existing ones, energy architectures, and we kind of put everything together. And the most important innovative part of this is the Semantic Interoperability Framework, where this level of interoperability that we showed at the beginning is really structurally used in the architecture that we are proposing. David, maybe we go to the next one where you will see a lot, because now, okay, at least we have the animation. We don't go all in one go. So we have, as mentioned, we have an ecosystem of interoperable services. We have energy services, typical of flexibility, forecast of energy, and so forth. Non-energy, which are more directly going for example, comfort of users, a lot of sensors and nice things in the building. Cross-domain and cross-pilot. Cross-domain because, well, you will see later an example, but for example, in the Portuguese case, you have commercial, you have supermarkets, but also EV charging. So then you have mobility that goes together with tertiary sector services and so forth, and energy flexibility, because it's also about that. And the cross-pilot. because another nice thing is that, well, we don't go each pilot delivering service, but we can cross them together. So in the example that I'll present in a moment about the Dutch pilot, well, there is an energy management system that can be provided by the Dutch partners because we have one platform that provides that. But we can also connect seamlessly to the energy management system that is in the Portuguese pilot, and still everything works because behind this there is the common model provided by the SAREF ontology. And there are a lot of well, standards, like we based everything on, especially the ontologies, then on ETSI, SAREF standards, and Senelec, you will see in a moment in the Dutch case, W3C, because then we're using also their ontologies and so forth. And stakeholders, David already mentioned anyways, who are in there. We have R&D consultants, manufacturer association, DSOs and retailers, and then maybe we go to the next. So we have several platforms, and that's where, as a matter of fact, what happens. All different platforms, and they work perfectly. But sometimes, if you are not in the same environment of that platform, then you have this problem of interoperability. And imagine in this project with 50 partners, with all their multitude of platforms, it was really, really an essential problem to solve. So we put on top of that, and of course, you have all type of assets on the edge, because then you have all the appliances, sensors, or energy managers, and so forth and so forth. And they can all offer services. But we put on top of this semantic interoperability layer. So somehow we adapt. So we don't ask to change the platforms. That would be crazy, impossible. Nobody wants to do that. But if some platform, someone has the need to become interoperable for some use cases, doesn't mean that you have to translate everything, but the parts that you want to interoperate with some others, then you have to create a service adapter. So it's one part that allows you to go from your way of encoding and exchanging your data, for example, like usually in JSON, we have a lot of JSON data that we transform into the common ontology, the language. So then the result, it will be a serialization in the ontology language. The data is the same, it's just a different format. But being the formats the way that everybody is using as common parts, then the interoperability becomes possible. This happens because there are these ontologies that I mentioned. There is a specific technical solution, which is called the knowledge engine, which allows to exchange this knowledge and find knowledge, discover. So by using this knowledge engine and this layer, you can ask who has certain knowledge, and then comes back to you the type of knowledge that somebody. So if you need some data that you don't have, for example, you can ask via this mechanism, and you can get back some results. And there is some reasoning, meaning that you can do some smart things with them. So not only you can ask for something, but you can ask for something, there is some reasoning, and somebody else can tell you, well, actually, you might need these things. And on top of that, there is a service store, because all the services that are described and built using these connectors and this translation to SAREF and to the ontologies are then made available. So there is a service catalog. So it's very flexible, because also third parties can enter into this ecosystem, like it happens now with open calls, where new services will be developed based on what's already there. And of course, you have everything. Technically, we are providing an interoperability solution, but you need all the other parts of certification of service, access policies, identity management, and so forth. Because, yeah, the data is there, can be shared, but you need to have some access control and something into that. And we have also the peer-to-peer marketplace. All that part together forms what's called the interoperability framework. And what we are focusing now here is the semantic interoperability layer, basically. Okay, David, if we go to the next slide. No, it's not finished, because of course, yeah, very important. Yeah, this is, we have then these other aspects that go through all the layers that I just mentioned, obviously, because then we're talking about security and privacy security and admin governance. And these use cases that we mentioned, they go, including the interoperability, those services and standardization, they're not in one specific level. So at the end, you can find them in all different parts. So there is a little bit of everything, of course, in all the layers that we mentioned. Okay, next slide. Now, how does this translate in practical examples? Because we've been very, very abstract until now. Then I'll give the example of the Dutch pilot, and you can, if we go to the next slide. Thanks. So the Dutch pilot, in particular, there are some partners, and of course, one of them is TNO, and we have also Vrije Universiteit Amsterdam. And the most important that you see here is ICT from Volker Wessel. So Volker Wessel is one of the main construction company in the Netherlands, and all the other ones that you see there are some daughter companies there, like Hirte and then Volker Wessel Telecom, because this pilot is about Dutch. It's being carried out in Eindhoven in a new building that is called the Next Building, which is a 22-story building with 160 apartments, which are all equipped with smart appliances and smart sensors. You will see. You can also see a nice video later on if you click on that link, which shows you more what happens there. But what's important is, well, we want to show an example. It's one use case. Remember what I said at the beginning, there were more than 112 use cases, so we're showing one use case, but at least it could give an idea of how these services can be built. David, maybe we go to the next one. And one of these use cases is quite simple. We're talking in this case about smart appliances, dryer, dishwashers, whatever. We start from use cases that are standardized, and one of these is that it's called the smart delay, smart start to lower tariffs and green energy, which means that as a user, we give our flexibility. We want whatever, the laundry to be done by 7 a.m. or it could be our electric vehicle anyways that should be charged by a certain time, because if we need to go to some emergency in the night, you still want a percentage of your electric vehicle to be charged. So anyways, what happens is that then all the demands by the different devices that are handled are given by an energy management service, and the energy management service will take into account, of course, what are the offers, what are the prices, and actually the availability of energy. And eventually also with some producing devices, because it might be that there are also some PV panels and other producing devices or that energy is stored in batteries and so on forth, until the moment it's able, of course, to do something smart and give back the starting time to the washing machine, dryer, or dishwasher in order to fulfill the user preference to be ready by latest end time. And if we go to the next slide, what happens in practice is that users can do this by setting times and so forth in their washing machine or dryer. So we're talking here, for example, about Siemens and Bosch and Miele devices that we have in the Dutch pilot. They are all partners in the project. And or you can do it via the app. So you can do it via the app of Siemens, for example, the one provided with the appliances, or you can do it with third-party app, which are actually managing all the devices in the home, or you can even build one. We have also other pilots that build their own app for users, and that's what it's nice, because these are all services that can be interchanged, also the user interfaces, because we are using this RF data behind. Then you have the energy management service that I mentioned before, and those two, if you look, for example, these Siemens devices and the energy management service in the Dutch pilot, for example, is built on top of a Reflex platform already existing, which uses a standard. You can see it's there, the number of the standard, which is commonly known as 2 standard from Sensenelec, while the appliances are talking another language, which is natively, which is the Spine IoT from eBus, which is also Sensenelec standard. standard. So at the end, the translation, what happens? There is the magic of the, knowledge engine semantic interoperability framework. Well, it's not a magic because it comes for a price, of course, but after you do that, it's really worth the effort, because you gain a lot in communication and interoperability with others. This gets translated to SAREF data, and that's how the communication between different...
Laura, it's Eva, just to warn you that we should close the presentation. Yeah, just to give the floor also to questions from the audience.
Absolutely. I think I give it back to David. At least he can say something about the other use case.
Very good. So I'll try to sum it up in 1 minute. So very quickly, as Laura already presented a lot of the details, I won't dive into the semantic part and implementation. Just to say that one of the points that we've made available within the project and now with the cascading and everyone that wants to join, is actually this framework of semantic interoperability. Where basically what we did is to have this framework available for those interested in using the same methodology to adhere to this concept of the semantic interoperability framework, which they instantiate in their own IT and OT systems, and basically can create what we call, and what Laura already mentioned, the semantic adapters to actually bringing their own system. So the question is to actually create the conditions for that to happen. In the Portuguese case, very quickly, we are talking about several types of building, although the commercial buildings are the point here. And although these are paramount objectives of including additional renewable and being more flexible, ultimately what this boils down to is the inclusion of several different platforms. So we have platforms from each of the supermarkets, where we have the supermarket owner managing the supermarket, where they have even entities that are responsible for use of energy, where they have existing automation systems, in this case from Schneider, and local controllers that needed to be integrated in different other platforms, like the one that you see here from Sensinov, which is the middle layer here for the building operating system that manages or is capable of managing the whole store. So the integration here from the semantic side and interoperability with the SIF was made within the supermarket itself, where we have two different sources of flexibility that are highlighted here. One of them is the use of flexibility of tertiary cooling systems, and also, as Laura mentioned at the beginning, the inclusion of electric mobility, which is something very dear right now for this kind of applications, which the end user also can go there besides shopping to charge their car. So on top of all of this, with the building operating system that Sensinov provides a sort of a bird view of different systems that we have here as SAREF compliant, we also have the interaction of the group of SONAI that manage the different buildings and manage the whole energy portfolio, and also the integration with the DSO. Just to give you an idea and to close here, perhaps to pass on to the questions, this is part of a bigger picture. So we're talking about here the commercial spaces where we can actually boost the service that they are planning there. And that only happens clustering the different Lego pieces that we're mentioning here. Again, platforms such as Refiflex that already exist within SONAI, with plug and charge management platform from FASEC, which is actually a provider outside the consortium. But with the use of the semantic interoperability framework, we are able to bring them all together in a platform from Schneider, for instance, which is part of the consortium, manage the whole system, and fit in the different platforms within the different supermarkets within the Sensinov platform, which ultimately then will have this bigger picture that I'm presenting here, which is interaction with the grid side stakeholders, namely the DSO and also the retailer. So there will be plenty more to talk about here. We are including also the residential side to the discussion, but this will be part of other presentations. So thank you very much. Sorry for the a bit long, taking longer than usual. We're open to discussions, to questions.
Yes, indeed. Thank you, David. So first of all, I remind people that are connected remotely to our session that they can put questions. They have a possibility on the right side of the screen to type their question. So maybe we might be a little bit late in replying because we needed to visualize it, but there is this opportunity. And if the speakers agree, I would prefer to have a couple of minutes of questions after each presentation rather than moving all the questions in the end. So for the audience, do you have any question for David, Laura? No one, in case you can come here. So I have one question, maybe it's more a curiosity. In the architecture that you presented, you have this aggregation of data in the platform with some services, but I understand that the data will be physically stored remotely. So you have distributed repositories, and the semantic interoperability layer is offering services that are operating on data that are not injected into the platform, right?
It's a very good question. I can jump in and Laura can complete. This is one of the points that I was mentioning. We don't host a platform ourselves, or doesn't anyone in the project has a single platform where all of this exists. So what we create is a framework. It's like having a sort of a fishing rod for partners to go catch the fish, so to speak. So we don't have, for instance, although we have the part of the coding and the framework itself as code repositories in our own repository at INESC TEC, since we're coordinating the project, the instantiation on the IT platform is made by each of the partners. So they decide on how they want to have data stored there. And this is critical not only for what we already discussed, but also in the case of commercial participants with the reserve of some of the information due to trade secret and competitive advantage and so forth. So what we have is a framework. The framework is instantiated using the same rules by everyone, and you select which part of the framework you need to use and what you valorize more. Ultimately, all of the pilots will make use of the different angles of the semantic interoperability framework, but we don't host it. So it's part of each of the pilot owners to instantiate this and make use of this platform.
Thanks, David. Any other question? Okay, so no question from our physical audience. In case there is any question from the people that are virtually following, we will leave you the opportunity of replying. So let's move to, so thanks again, Laura and David, and we move to the next presentation, which is, so we have to share our screen.
Exactly. Entire screen.
Okay.
You have to select. Back to the PDF. This one, no?
This one. So Elizabeth, if
You ready?
if you're ready, we can put your presentation on the screen.
Yeah.
Okay.
Can you confirm you see the slides? The other speakers, David?
Yes,
We do.
Thank you.
And I can just speak anywhere?
In front of the
Yes,
laptop.
we can see you.
Just take care of the table.
Okay, so Elizabeth, please, you can start when you want. Just a short introduction. I think that we are now approaching a different perspective, which is more related to certifications of data and not so technical as the previous presentation. So the floor is yours, and again, people from remote can put questions, and if you can stick in 20 minutes, I think.
No problem. I'm also going to invite my colleague Martin up after he takes a good picture. Like all good Norwegians, he's very chatty and loves questions. So we'll have put some questions to him afterwards. My name is Elizabeth Nelson. I'm from the Smart Building Collective, the owner of the Smart Building Certification and the Solution Certification. I'm also a researcher. I'd like to know a little bit about you. Can everybody stand up who is a researcher? Nice to move. No, stand up. Yeah, we haven't moved for a little while. Yeah, only 2 people are researchers. Yeah, a lot, right? And do any of you work, we can do hands if you want. Do any of you work with companies to do your research as well? Yeah? And who thinks it's super easy to do research with companies and always fast and efficient? Yeah? Okay, I would love to hear about that. Okay, so I want to talk a little bit about my story, some of the things that we're doing, an amazing building that we're working with, and a new way that we're trying to approach certifications. So the current state of SMART, I don't know, the topic a couple of years ago was what is SMART, trying to define what is SMART. I don't even know if we've gotten there yet. I'm going to take you through our certification, Houseman's House, one of the world's smartest buildings, our lessons learned, and some final thoughts. So, I was going to ask, does anybody know when the first smart building was invented or around? If you saw my slide, don't say. Guess? Okay, So I'm saying this as someone who lives in the Netherlands. So I've had some bad feedback from other European countries. But so 400 years ago, there was a Dutch inventor called Cornelius Drebbel who invented a smart chicken coop. So this was a coop, a chicken house that regulated temperature, airflow.
Other researchers are connected online and they're working with comments.
Oh, great. Thank you. Yeah. So it's kind of amazing that we built 4 centuries ago these incredible buildings that regulated airflow actually pretty amazingly well. Then what happened since? We maybe took a couple of steps backs and also took a couple of steps forwards. So if you look in the Netherlands also, almost 400 years later, we had the Edge pop up in Amsterdam, right? A building that was incredibly wired, that had a ton of technology in it, but the data used was a bit of a mystery. What were they doing with it? Who had access to it? And what were the implications? So what have we done since? So what is a smart building and what is not, in our humble opinion? Do you need anything?
I'm really sorry. I just want to activate the video because
You
people
want to see
can't
me?
see you. Yeah.
I don't know if that's
For those
worth
online,
doing.
I'm really sorry for that. Now that should be.
Okay. For everybody online, I'm wearing a what we call, where I grew up, a Canadian tuxedo.
I don't know if it's just me, but I think we lost sound. I don't know if you're hearing me, so I'm just saying this. I don't want to interrupt, but at least I'm not hearing. I don't know if you changed the microphone, but I stopped hearing.
I also cannot hear anything.
Right?
That seems.
It's a good fish. Okay.
Now we see you.
Video is on.
And sound?
Sound.
We can hear you. We can hear you.
It's good. It's good again.
Yay. Woo-hoo.
But it was a good description that you made from your outfit.
Perfect during technical problems. Well done.
Okay, so what we say is a smart building applies data to drive autonomous controls through an integrated design approach, connecting systems and processes together to deliver improved health and wellness, human performance, comfort, efficiency, safety, and security. Those are the pillars of our certification. And is smart overused terminology? Everyone is claiming smart. There's a bit of, we've had greenwashing for quite a while now. I believe we have some smart washing as well, especially in kind of the commercial sector. Everybody's smart, but I think the people who actually are usually the ones who are most curious, which I will get to later. So here's a look at our philosophy and our layout. We have different pillars that we measure: building usage, building performance, also called sustainability. Funnily enough, when we first started talking with the multitude of experts to develop this methodology, people said, don't say sustainability. Everybody wants to do it, but nobody wants to pay for it. So this is something that's coming up, but I think sustainability is really finally gaining a little bit of oomph, and this conference is a great example of that. So user behavior and collaboration, this is everything from controls within the user to how they meet and use the building environment, safety and security, and then it's all interconnected with integrative design. So I can share my screen, my slides later. This is a little bit of a breakdown of that. We also look at interesting aspects of it. So smart building certification is not a checklist, and I'm going to say something quite maybe not profound. That's a strong word. Maybe a little bit strong, but I don't think that a smart building certification can be a checklist. If we're going to make any progress, if we're going to innovate in ways that optimize buildings, that work with the way that we want to work with buildings, if we're going to make progress, we have to have a system that recognizes greatness. And we've seen that with other certifications, that a checklist can have a mark in time, but it cannot recognize great innovation. If you look at the Swedish Nature House and the strides that they took in building different buildings, it's incredible. It's a really good documentary about that. So we have experts look at all of our buildings. We have a quantitative measured part of our certification. We also have a qualitative aspect where experts look at this and break down not only what they see in the building, but what they see for improvement, because our business is certification, but of course our mission is to make better buildings. Then I want to talk about one of our best buildings, actually, and possibly our best building this year. So Houseman, I'm not going to pronounce it right. You say it.
Yeah, try it.
Houseman House.
It's Norwegian. Houseman's hus.
Hus, sorry. Originally built in 2000, and it's a retrofit. This is one of my favorite things about the smart buildings that we're seeing right now. Everyone is saying, oh, you can't have a truly smart building if it's a retrofit, or you can have a truly sustainable building, but you can. And it's something we're seeing over and over again, especially in the Scandinavian countries. It's going to be completed in Q1 of 2023. It's an office building, and like I said, it's one of our platinums and at the highest level. So the normal building, I think we all know what consecrates as a normal building. It's over 99% of buildings these days. When we look at the different aspects of it, it's a standard approach that isn't working, and it's something that we need to innovate. Hathon, as a business case, owns all their own buildings. This is something that we're seeing with the best transfer of buildings. So a lot of times builders are nervous to make a ton of different functionality into a building that might get lost in translation if it's transferred. So the builders that are actually owning their own properties and keeping them have a little bit more control and maybe even pride of ownership and confidence in that. So it's something that we're seeing over and over. The goal was to make the building deliver the functions people want and expect. I think one of the most amazing things about this building was that it started with the people and with sustainability. We were on a call the other week, and I said, he was in his car, and I said, oh, do you have a hybrid? And he said, no, this is Norway. It's an electric car. But there are certain standards that are coming out, and there are certain standards coming out in Europe, and certainly Scandinavia has got some initiatives that are going for themselves within sustainability and this sort of thing. And as American, I also think it's maybe even fun or funny to poke a little bit that America doesn't know that it's not winning the smart building race right now, because it's expected, but it's not something that's been put in, because a smart building is sustainability. It is health and wellness. It is how we use the building and the flexibility of the people in it. So quality and sustainability were the goal, and smart was the why and how. So sustainability, so a recent study showed Europeans will spend 36 years in the workplace before they retire. I was going to say die. That's a terrible thing. That's more of the American approach, right? Some of the first smart features of buildings were implemented to improve sustainability, specifically energy and efficiency. And often there's a gap between energy use and the design and duration of operation. The smartest buildings are also the most sustainable. This is what we're seeing. It's got that backbone. It's something that there's great initiative there. And no smart buildings we're seeing are ignoring sustainability. So Do you want to talk about the given of sustainability? Chatty Cathy?
Yeah, I think also because of the BREEAM certification. And we were told that we should do BREEAM because the customer will expect it.
Yeah.
I still haven't met some tenants that really care. So it's the financial institutions, the banks, that are actually pushing the green, the sustainability aspects to ensure their assets. And we also, it's both sides. We have the strategy to be sustainable, but it also gives us credibility at the banks. So you can't build or refurbish a building in Norway without sustainability certification, because eventually you won't get the loan. So that's two sides of why it's given.
Yeah, and that's something that we're seeing with other banks as well. We're expected that, so we had the first green mortgages a few years ago. We're expecting the first smart mortgages to come quite soon after. And whether or not that's demanded for the building or not, but it's just an asset for buildings that are building this is to be seen. So indoor environmental quality, this is my favorite area and my background. It's also what a lot of what my PhD was on, looking at the health and wellness of people. When I was working in my dream job in the US, I started to work a lot, overdoing it a little bit. And when I fell asleep during a bikini wax, I realized I'd burned out in the job that I loved. So I put together this PhD to look at how can we change the way that we work and how can we do that in different environments. Now, the US has the highest percentage of people planning to quit their jobs in the world currently. And we're treating health as a luxury. But now we're seeing a lot of people demand for better circulation. And when you look at this, we work a lot with the best workplaces or the luxury workplaces right now. What we hope to do is normalize this so that the places where maybe our most precious people, our nursery schools, our retirement homes, also have this kind of health built into it, because the environments that we're working in are just terrible for us for the most part. Sensor placement is important. We've done a lot of implementations where sensors haven't been placed in the right way, and systems have to be installed properly and regulated. And then CO2 is a versatile measurement. It's also the best measurement for occupancy. But one of the things that we're seeing, so Houseman's Hus, was that better? No, it wasn't. Okay, I'll get it by the end. They're going to display real-time measurements of air quality. So some of the research has also shown that having this kind of display, having this sort of control or feeling of variability is, or display of information is incredibly important. It's something that can have a drastic implication of how people feel about an environment. Although if it's not in line with their own feelings, there can be, as some research have called, a fracture in their sense of self. So the stigma of safety is one of the most important things that buildings have to look at. But right now there's a bit of a stigma on it. Who is it for? Safety is this idea of something the building is doing to protect its assets, not necessarily what the building is doing for your benefit or to protect you. And I argue that this transparency within safety is absolutely key in adoption in smart buildings. We had a great living lab where the students in the university ripped off the sensors from the wall because they didn't want to be recorded in this area. And we've heard about that at least a lot. That being said, looking at the type of recording, it was a infrared camera, so not something that would have been a big concern. Or maybe you disagree, and I'd love to hear. But maybe explaining and showing why people are being monitoring is such a key thing to do here. And you guys are using security cameras for different purposes, and I think that's something that came out of.
I think it's crucial to try to minimize the gadgets you put in your buildings. So then you should maximize every single component you add to the building. So by having a smart camera, we can use it as a sensor. So we do people counting, we can even trigger functions in the BMS. And so we try to do the most with at least. I think that's crucial if you want to actually have control of the building at the end. Because as a representative for the building owners, I would say my industry, they're driving blind. So we need to do it easier, or more with less.
Yeah. No, and that's something that we're seeing where we have buildings that score very, very similarly. Some of them have 30 technologies, some of them have 6. So we really believe that this is going to be condensed down in the future, and a lot more technology partners are willing to work with each other and work on more projects together. But that idea of having kind of a lean machine. So building users, I've already talked about a little bit. Here is a paper that we wrote, or a piece of writing that we wrote on the return on investment of smart buildings with Dr. Heather Ray. She is a great thought leader in our industry as well. And Houseman House really began with the users in mind, so the satisfaction. So final thoughts, smart is, in our mind, is solving a problem or optimizing something. It's not a technology. And then, as I said before, smart and sustainable don't need to be retrofit. Not all smart buildings are the same. It can be captured in a checklist, and we have to begin with the end in mind. And then this last one is something I really would like to hit home and maybe talk with you. Smart is an ongoing experiment, so being a scientist. So we believe that the approach to this data needs to be curious, needs to look at once those sensors are placed, are they operating correctly? Is the data that you're getting actually good data? What are you planning to do with this data? And that's why we're working a lot with different scientists, and we're opening up all of our buildings to research projects. So if you're interested in becoming a research affiliate, becoming a partner, if you want help with any of the grants that you're doing, I'll get out of the way. Tuxedo has to move. If there's anything that we can do to help, we absolutely know that we need research involved in this, and that your insights can help, because the buildings that we have right now and the builders are incredibly curious people, because they've been working on this for 4 years, 5 years, more. They're not waiting for that black box, and they're very interested in finding amazing scientists to look at their data and do something with it, not just say that they have technology in their building. So we'd love to have you involved. He would love your questions, and thank you so much.
Questions? Come on. Now you have questions. Okay, can you come here, because I'm not sure that people
Yeah.
can hear you.
So you're just a bit of paid away from being the full Canadian tuxedo.
Yeah.
So thanks for that. That was a very good presentation. You showed the edge at the start, which is a very smart building. But a lot of the technology that's been installed there in later years has been proved that doesn't really add anything. No one really uses it. You know, people would rather get up and go find someone than look where they are. And then there's other kind of aspects. It depends on the level you're talking about what smart means to them. So for like a building operator, it's all HVAC stuff. For a person who works in the building, they might want to turn their coffee machine on before they leave. So based on your experience in this certification, what has been kind of the sweet spot between being smart and being, not practical is not the right word, but like adding value, I guess?
Yeah, so absolutely. I love that question. So one of the things about smart buildings is I think there's more stakeholders than pretty much any industry, and there's so many people involved. The reason I show the edge is because it was this idea of smart, you know, but you didn't see it, you didn't feel it, you didn't know what was going on there. So it's this idea of wiring a building with technology versus having a building that operates better because it's smart, and also you operate better and you realize it because of it's smart. So we know that as a certification, we get hired sometimes, or we also get hired because people can sell at a premium when they have certifications. They can rent out faster, or they can rent at a premium. That's part of it, and that makes a certain stakeholder happy. But that's not a mission. That's not worth doing if you're going to do something, especially when you're creative enough to actually make something better. So I think in our rationale and also within our certification, if you're just wired for technology, you're not going to get a very good score. You have to show that you're forecasting, that you have a connection to the data, that you have simple tools that actually work, that your team can work with. They had a technology where we had a bit of a question because it was very, very simple. And we said, is this smart? And actually, it was probably the smartest thing that you could do because it took so many complicated things into a simple Excel chart. But it told them exactly what they needed, and it told the right people at the right time. So it was about the output of that. And I think, does that start to answer your question? Okay, yeah. Yeah, hi. You can also say it, I can, no, you should probably say it. Okay, yeah.
Not be able to properly do. Do you have any thoughts on do-it-yourself sensor installations, whether they can work in terms of making, the smart functioning of buildings more accessible?
Yeah, I have strong feelings about installations. I don't think installations of even the simplest technologies are often done 100% correctly. I was at one where thermostats were installed facing the windows, so that as soon as the sun shone in, it registers at 28 degrees, and then cold air poured out in. So I think the key is really getting the person who installs the technology to also be looking at the data and see if it's any good or if something's wrong. I remember just with the little health sensors, everybody loves to put them by the fan of the TV so that it also registers really hot. Because it looks really nice, but it's the technology wall, right? It's just the tech doesn't work anymore. So I'm a big fan in getting started, doing living labs, getting people involved, but whoever installs also needs to check that the data is actually good because, yeah.
Yeah, there's a question.
No, you can talk. See, he's so chatty, right?
Yeah.
Thanks for the presentation. I was just wondering, you mentioned that this is not, you don't follow a checklist kind of format. So how do you assess a building's, how a building would be considered smart?
Yeah.
And how do you consider I know you mentioned forecasting right now, but what else do you take into consideration in terms of operation? Do you do some kind of a feedback after it's operating? Do you give that time for monitoring or verifying if it's operating as expected?
Yeah, good question. So what we did instead of a checklist is we have a very large, exhaustive, dynamic questionnaire where you start filling in what your building technology involves. And the more that you check, the more questions open up. So we have had a couple of people who said this is a very short checklist, and we said, oh, that sucks. But for the most part, it asks you the right questions for what your building is, and then has certain algorithms to check for consistency, and that we look at that. We do different certifications for if something is being built versus in use, of course, and then we regularly, it's a 2-year certification. So a certification is only good for 2 years, but it's saved in the system. And so it will tell you, we're about to tell the buildings we did 2 years ago what their score is, because the ceiling is based on the smartest building in our system. It's not on a concept of a smart building. It's actually the smartest building in the smartest categories. So we have a few buildings that did really well 2 years ago that will get a unfortunate email, possibly, that they've downgraded. We're thinking about sending that on a Tuesday because that doesn't feel like a Good Friday email. But does that answer your question? Great.
There's a lot of talk of data and data handling and management. And for not just this project, but a whole portfolio, my main concern is how to actually own the data. So we developed our own data platform in Azure. So for this building that is also divided, it has quite good flexibility. So we can divide floors and everything into different sections. And we can also pinpoint the exact use of each tenant. And everything is stored in our platform. That means we also have, it's easy for researchers to get reach the data. And we also connect with a lot of metadata. And my focus is not what to do with the data for the moment. I just want to ensure that we collect it rightly, that we are in charge of it and can share and do whatever we want. And that's why I also hope someone who are interested in quite a good level of detail would reach out, because we have the data.
Yeah. And since the building isn't open yet, you have a nice opportunity for a pre-post if you'd like. So reach out to, and I'll say that since they're moving in Q1, they're open to a pre-post research with companies. You can email Martin or you can email me for that. Yeah?
A very simple question.
Oh, yeah.
In your project, who owns the building?
In his project.
Yeah, in principle, if you run such kind of project, who owns the data?
Who
owns the data?
Who has the right to? Who owns the data?
I own the data.
Oh, okay.
I'm the representative from Hatun, so we own the building. That's clearly stated in all the contracts that we shall, it's not can or should, have data delivered on MQTT to our base. So yeah, that's an absolute. Yeah, it's my data. It's in our platform. We control everything, every aspect, every metadata, everything. It's in our own database. So it makes it easy for us. And since we're using data from cameras and everything, there's also a push, so we don't connect to the server for the data for the cameras, so it's completely anonymous. So we just ensure that we are in charge completely. There's nothing to doubt about, and yeah, we're up and running on this platform now. So we're collecting a shitload of data. And there's so much to do about it because we have people counting. So we started this new KPI, and it's called CO2 emissions per day's work, because we think that the function of a building is value creation. It's not just house people or something. So instead of measuring, we do measure kilowatts per square meter, but I don't think that tells you how good the building is working for the people inside. So then putting the environmental footprint on the value creation, I think that's we think it's might be a good way to measure it.
Yeah. All right. Thank you.
Thank you, both. And I think that it's time now to move to our last presentation, because unfortunately, Dominic. Okay, so
is that one?
Yes. Okay, so be careful. Yeah. So Jana, I leave the. How much time do we have? We have more or less 20 minutes plus 5 minutes for questions. Then please tell me 5 minutes before the end. Thank you. So I would like to present today the mechanism sale of receivables from the energy performance contracts, which is applied in the Czech Republic. We describe this process within the Refine project, and why I think it may be useful to present how we do it in the Czech Republic is because in many countries, many countries in Europe, the financing is reported as one of the main barriers why there are not more investments in energy efficiency, especially via energy efficiency services. So first, I will start with a little bit of information about the Czech EPC market, and then I will talk about sale of receivables, about this mechanism. Do you all know this energy performance contracting? Yes. Okay, so I will not go into detail, but I will say that it's about the main thing is that EPC provider carries out a comprehensive energy efficiency service package, which includes design, implementation of energy efficiency improvement measures, operation, maintenance, financing, user motivation, energy management, etc.
but it doesn't have to include all of these components. There are different combinations and there are different ways how it's done in different countries. And what is very important is when the EPC provider fails to achieve the performance, the expected energy savings, which are specified in the EPC contract, the provider has to compensate for this gap. And this is one of the main advantages for the client. The Czech energy performance market, energy performance contracting market ranks among the most developed in Europe, but not so much, the country is not so big, not so much by the number of the projects, but by the way the contracts are standardized, the process is standardized, and it's hard to find like the project which fails. There's almost no case. There has been 270 projects implemented between 1994 up to 2021, and there was 170 million euro invested and about 200 million euro saved in electricity, gas, heat, water, and other operating costs, including also wages. So typical EPCs in Czechia focus on implementation of technology, energy efficiency improvement measures in the field of building technologies, equipment, etc. The payback of the measures is usually less than 10 years. Now, because it's possible to combine EPC project with subsidies, it's possible to include also measures with longer payback. A contract duration is usually between 8 and 12 years, and the projects typically include energy management. When we did within QualitEE project, we did a survey. What are the market barriers of the Czech EPC market? One, it's not growing more because it's still there are 10 projects implemented every year, and the projects are good, but it's not growing. And the main barriers were administrative barriers, and the fact that public institutions see it as the preparation is very costly and demanding. This is a huge barrier, and there's also lack of sufficient of the governmental support. Though the Ministry of Industry, in some periods, it's really trying to support this, there is lack of support at the other ministries. What is interesting, Czechia is one of maybe the only country or one of the two countries which don't mention financial barriers, as there are almost no financial barriers. 91% of the respondents, the providers and facilitators of EPC reported that financing is easy, it's accessible. But this was not the case in many other European countries. So what is it? Sale of receivables. After the energy performance contracting project is implemented, the energy efficiency measures are installed. The client signs handover report that the equipment is working, that the measures are tested well, and he commits to the payments over the contract period. So he pays for the project not at the beginning, but through the installation. Usually it's every quarter of year or every half year over, let's say, 10 years, if most of the contracts are for 10 years. So the EPC provider usually provides financing. So he would get the payments from the client over the contract period, which is usually 10 years. But he needs financing for new projects. So by selling the receivables, he obtains financing for new project, and that's one of the main advantages. Another advantage is that the EPC providers are not used to assess the creditworthiness of the client. They don't want to bear the risk of the non-payment by the clients, and so it's useful when the financial institution which buys the receivables bears these risks. So these are the two main advantages. Who is offering the service in Czechia are two private banks, Československá obchodní banka started in 2005 with this approach, and later on Komerční banka saw it's working and they joined and started to use very similar scheme. The providers are experienced privately owned EPC providers, and most of the clients are the public clients. In the private sector, we have maybe just a couple of % of the projects where the receivables were sold, because usually if there's a corporate client who is interested in PC project, then they see they could save energy and they think they can pay for it. They don't need EPC contract. They can invest themselves and gain the benefits. So usually, even if the project starts EPC, then it changes to some other service or agreement. The client usually knows he approves the sale of receivables before it happens, but it's not required by the law. The law requires only that the client is informed about it. This is different in every country. There is agreement on future sale of receivables between EPC provider and the bank before the EPC contract is signed, and this is important because the bank offers already the fixed discount rate which is later applied for a sale of receivables, so the EPC provider can include the cost of sale of receivables in the EPC contract. So, of course, there's EPC contract signed before the sale of receivables can happen. And here you can see the scheme. So first, according to the EPC contract, the measures are implemented. The provider provides also financing in these projects. After the client confirms the equipment is working in the handover report, the EPC provider acquires receivables. Then he, based on the receivables purchase agreement, sells it to the bank. And the bank sends a lump sum payment for the receivables, which is like value of receivables minus mainly it's the discount rate. And then EPC client doesn't pay this the payments over the contract period to the provider, but to the bank. So here I have the details of the process, but I think this would be interesting for somebody who wants to implement it. Maybe it's not so interesting for you. So I will skip this. What is the cost of refinancing? The costs are mainly the discount interest, which consists of the basic market rate and the margin of the bank, which reflects the creditworthiness of the EPC client. Because the process is standardized for the public clients, the costs are quite considerably low. And for example, for municipality, for the contract over 10 years, it's usually between 1 and 1.5% per annum. Of course, now with the interest rates growing, now it's much bigger problem for the bank to say before the project is implemented what will be the discount rate they charge. And the EPC provider also pays some fee to the bank, fixed fee. So what happens after the receivables are sold? The risk associated with the EPC project are divided into technical and financial risks. The EPC provider keeps the technical risks. He's responsible for the performance, while the credit risk is transferred to the bank. As I said, this is also one of the main advantages for the provider. The bank assumes the risk of the client's bankruptcy only. So the EPC provider further He keeps the risks of the meeting the guaranteed energy savings, which he promised in the contract. If he doesn't achieve them, he has to compensate the client. He's responsible for the design risks and implementation risks. In the Czech Republic, the provider doesn't, usually in most of the cases, the provider doesn't offer operation and maintenance of the equipment. This is also different among the countries. We also had a case study within the Refine project. We had case studies describing also sale of receivables in Austria, in Belgium. This is just a copy of the process which you saw. The process is the same. There are little differences which I can talk about. In Belgium, it's the one bank who created such process with the energy efficiency service provider Watson. So there's just one cooperation, and they don't have many projects. In Austria, it's the major energy efficiency services provider, Siemens Building Technologies, in cooperation with Siemens Financial Services. If you want to know more details about these cases, I can refer you to the Refine project website. You can look for case studies on existing refinancing instruments for energy efficiency services. So what are the differences? There are not many differences among these procedures. Usually, it's the providers with whom refinancing institution has had a good experience, who has access and is able to sell the receivables to the bank. And in the case of Austria, it's even like it's selling one company to the other one where they have the same mother company. So it's very close cooperation. In all these countries, it's mostly the public sector. When it's the EPC project in private sector, it has to have very high creditworthiness, and there are only very few projects. In Belgium, they don't have any case of the private sector project. In all cases, it's the sale of receivables without recourse to EPC provider. That means if the client doesn't pay to the bank cannot go to the EPC provider and try to get money from the EPC provider. What is the difference in Austria? The refinancing institution holds title on equipment, which is asset-based collateralization of receivable. For some reason, Austrian financing institutions value the title on equipment, though it's very difficult to sell the equipment once installed. It's somehow easier to sell such a receivable on the secondary market. What is the main difference between these schemes is that the Czech scheme is, or in Czechia, this is widely used. It's most of the projects go through this process, unless when the provider is big and doesn't have problem with financial sources at all. So we were thinking how this could be supported in Austria and Belgium. So there are more projects. What came out is one idea that the Czech banks actually could buy receivables from the projects, for example, realized in Austria. And both Czech banks said they would do it, but only in what is interesting, they insist that the EPC provider is Czech, coming from the Czech Republic. So it has to be the Czech EPC providers who goes to the other markets and bring this mechanism there and could do more projects. It was difficult before. It's possible now in Czechia to combine EPC projects with subsidies. And in that case, it's also possible to include building envelope measures, which have longer payback period than 10 years. But it was difficult to do sale of receivables in this case because of administrative barriers, because the fund which is providing the subsidies required that I show you on the scheme, that the client who is receiving the subsidy confirms to the fund that he sent all the price, the total price, to the provider. But when sale of receivables is applied, the part of the amount, financial amount, comes from the bank. So it was not possible to prove to the fund for a couple of years. It was not possible to apply this. So the market actors created a three-party agreement. My company was involved in these negotiations and so supported this. This is possible now to sell receivables from subsidized projects. And this party agreement is the fund accepted this three-party agreement as a substitute for such confirmation of the bank transfer. So it's possible to overcome administrative barriers, but it takes time. Okay, that's all.
Any questions? I'm just checking if there's any question also for the other speakers in the audience. I don't think so. So any question related to Jana's presentation? No. I just have one question. You said that in the Czech Republic, the financial institutions are financing or buying the receivable also for projects that are implemented outside the Czech Republic?
No, but they would do that. They would do that in the case if the Czech EPC providers invest, for example, in Austria. They do a project in Austria. The Czech bank is willing to buy such receivables, but not from Austrian provider. That's interesting.
And this is a unique case in Europe, or other countries are doing the same?
You mean sale of receivables?
I mean, other countries where the financial institutions are selling a receivable also for EPC contract established in other countries.
It's not common. There are international institutions which, in some way, there's refinancing mechanism, not exactly like this, but yeah, this would be quite new, especially for Austria, because Austrian banks are not willing to buy
always
receivables.
With public institutions, or also for the private?
It's much easier in public institutions. It's much easier because the creditworthiness is high.
Okay. Okay. Any questions or curiosity? No? So thank you again, Jana. And well, I think that we managed to close with a little bit of, still we have 5 minutes, so we close on time. We manage the time also because we have just 3 presentations, but I really like the interaction we had. So I thank all of you and also people connected from remote for your attendance, and well, enjoy the rest of the conference and see you again in the next edition. Thank you.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Thank you. Thank you.